Okay. So we're going to do probability, but harder. We're first going to start with sample space, and let's see if I can get that back up. There it is. 2 rooms in a house need to be painted. Each room can be painted either white or yellow. Okay, so this is more of a complex situation. So there's 2 rooms. I'm going to name the room creatively 1 and 2. And the 2 colored paints are white and yellow. Okay, a lot of people, when they first look at this combination, you go, well, each room, so how many different, basically, how many different results could I get? A lot of people say 4 because there's 2 rooms and 2 colors, but that's not how it works. And so let me show you how it works. If I can move this here, let me show you how it works a little bit. So I got 2 rooms and I got white and yellow. And so this is how you do it. 1 room, you have a choice of white and yellow. 2 room, you have a choice of white and yellow. So basically what you could have is 1 white, 2 white. You have 1 white, 2 yellow. You have 1 yellow, 2 white, and you have 1 yellow, 2 yellow. Okay, so there's different ways to do this. I will accept if you just do it like this. It's less writing, but basically you can see that you have 4 choices here. Okay, and how did I do this? I did that. You could also just do, well, I have 2 here and 2 here, and multiply it together. 2 times 2 will give you 4. Okay, so I'm going to give you another scenario. I don't know if I have it here, but let's say you're getting dressed and you have, so we have shirts, we have a red, a blue, and a white. We have shorts. We're going to have a yellow, a green, and a purple. I didn't say this person was stylish. And we're going to have socks. White. We'll call this brown. We'll do a BR because I don't want to get confused with blue. And we'll do pink. Okay. I'll do PI, I guess, because I have purple. All right, so how many different ways could I get dressed? And not how many different ways could I get dressed and look good, just how many different ways could I get dressed? So you start with the shirts. I got R, B, W. Then I put on shorts. Y, G, P. And then I put on socks. W, BR, PI. Okay, you see how I did that? And so you got to do it for each one of them, basically. Okay, basically when you get this long, I'm just going to have you tell me the number. So how many total numbers am I going to get on this? I need to do, how many shirts are there? 3. How many shorts are there? 3. How many socks are there? 3. So it is going to equal what you said, which was 27 different ways to get dressed. Okay, so that's what we're going to work on. I don't have anything this long in your homework. And why don't I have anything this long in your homework? Because it is just kind of annoying and busy work. So once we start getting longer, we're going to multiply here. We are going to have stuff like this up here that I'm going to make you do. Okay, just to get the idea, but I needed to show you where it goes. Okay, moving on, we're going to do a little more independent-dependent. Where did it go? Okay. Let's go down to one of these. Let's go down to maybe We did that yesterday, didn't we? I think it gets a little bit harder. Okay, a cooler, let's just look at this one. I think this one's good. A cooler contains 10 bottles of sport drink, 3 lemon lime, 4 fruit punch, 4 fruit punch, right? And 3 orange flavors. 3 times you randomly grab a bottle and return the bottle to the cooler. And then mix up the bottles. All 3 times you get a lemon lime drink. Okay. Independent or dependent? Independent because you put the bottles back, right? So that means that every single time you pick, you're going to pick from 10 bottles, right? Okay, and if you're worried about showing your work to actually get credit, and I have to have you show your work to actually get credit because it's too easy just to copy the answers, just do this. This is all you got to do. So you want 3 lemon limes, right? So 3, 3, and 3. Multiply that together and you will get your fraction and your decimal. So let's get that done. I think we're getting what? 27 over what? 1,000. Yep. 27 over 1,000. And so, what is that going to be in decimal form? And let's go ahead and do it to 3 decimal places this time, just because we're going to have things like this. 0.27, I'm sorry, 0.027, right? And so you don't have to do this on this assignment, but I always like to do it. I like to translate to something I know. This would be 2.7%. Okay? No, not very likely that you'd be able to pick 3 sports bottles in a row, right? 3 lemon sports bottles in a row. Okay. So that's basically what we're doing. We're going to do that again. We're going to get good at this before we move on to the next thing. So I'm going to give you your work.